Hi everyone, my name is Fraser Kane. I am the publisher of Universe Today, and it is your weekly space hangout for Friday, April 26, 2013. There's a cat there, right there. So today we've got so many stories. I am going to be amazed if we'll be able to make it through them. So if you feel a certain sense of urgency from me, that's because there's a ton of stories. We've got a new test of general relativity. We've got meteors hitting Saturn's rings. We've got observations of Betelgeuse. We've got Hubble observations of Comet Ison. We've got progress arriving at the International Space Station with a few glitches. We've got a lunar eclipse that just happened, the launch of the Antares rocket, and the test of the Grasshopper, and more. So we're gonna be talking about a lot of stuff. So joining me, fortunately, we've got lots of help. So we've got my good friend Jason Major. We've got Dr. Matthew Francis, who joined us last week and is back with, who's the cat? Oh, you're muted, I think.
The cat is Dr. Matthew Francis. Who's
Dr.
that?
Matthew. Oh, I see.
The cat is actually that Futurama episode, right?
This is Pascal, and I will remove him before he starts yelling, which is what he's likely to do.
Awesome. We've got Nancy Atkinson from Universe Today. Nancy. We've got Dr. Nicole Gugliucci,
hello,
aka the Noisy Astronomer from CosmoQuest, and we've got Scott Lewis.
Hey, everyone.
My partner in crime with the Virtual Star Party.
That's right.
Okay, so then we're just going to start with, I think we'll start with Nicole, and we're going to talk about this really cool test of general relativity.
Pulsars, pulsars, pulsars. Pulsars are awesome. Okay, so this story broke yesterday. I don't know if you mentioned about comments. If you want to comment,
oh, right,
do it
of course.
in YouTube.
I'm doing a terrible job. Let me get
No.
So yeah, we
need
love
to make
your
room for
comments. We love to incorporate your questions into the show. So if you want to do that, you can go to if you're watching this on the event page on Google+, you can post your comments there. If you're watching this on the stream somewhere, you can post your comments just in Google+ on the stream. Hopefully we'll get it. I can't guarantee that. Also, if you're watching this somewhere and you just want to use Twitter, you can use the hashtag #SpaceHangout. Or you can use it on. You can post a comment on YouTube. YouTube's probably the safest place, so we'll absolutely we'll catch it on YouTube. So go ahead and post any questions. Although I'm not sure we're actually getting the YouTube video automatically. Actually, now that I think about it,
it was already listed there.
Yeah.
It's taking its sweet old time if it is.
Okay. Yeah. So
there's our comment. Thank you, Tyler.
Go. Post your comments. Awesome. All right.
All right.
So, Pulsars. When last we saw our heroes, it was Pulsars. Pulsars are awesome, I believe.
Pulsars. So there was a pulsar pair discovered. It's actually a pulsar and a white dwarf star, and the pulsar has the name of PSR J0348 plus 0432. Of course. This is this is a very interesting system because it's usually they do this test with pulsar binaries. This is a very close binary of a white dwarf and a pulsar. Pulsar is a neutron star, so it's this very dense material. It's so dense that it's all compacted, all the particles into neutrons, and it's got this these beams of light spitting out of both sides, and as it's spinning very rapidly. This one's on the order of 30 milliseconds. This is a very rapidly spinning pulsar, and it's got a white dwarf orbiting it. And so they were able to, a group of scientists, including a bunch of my friends from University of Virginia and the National Radio Astronomy Observatory, they detected the system with the Green Bank telescope, and then they did follow-up using optical telescopes, I want to say at Apache Point, as well as Arecibo, the Arecibo radio telescope. And they found out a couple of interesting things about this system.
First and the VLT in Chile.
And the VLT, right, the VLT in Chile, thank you. So they discovered a couple interesting things about this system. First of all, they were able to determine the masses of the pulsar and the white dwarf with extreme precision. That's really hard to do. And so they discovered that the pulsar was 2 solar masses. And then they used a technique called Pulsar Timing, where they actually measure the time that each pulse comes in from the pulsar with an accuracy of 10 10 microseconds. So with an accuracy of 10 microseconds, they can get the exact orbits and the exact motion of this system. One thing that they found is that they could use this to test a regime of general relativity that they haven't been able to test before. The general relativity is this theory of gravity that seems to work in all cases, but we know it probably breaks down somewhere because it doesn't mesh with quantum mechanics, right? And so physicists are looking for this grand unified theory of everything, and so they're looking to find the places where general relativity is going to break. Turns out this was not the place.
Einstein was right again.
Einstein was right again. But it's a new search space that has been probed that way. I think, Matthew, maybe you're a little bit better schooled on general relativity than I am, if you want to talk about some of the implications.
Well, one of the things that's really interesting about this particular pulsar is, one thing, back up for a second, one thing that is interesting about pulsars in general is that they are so small in relation to their mass. So a pulsar, did you already say this, Nicole? Mm-hmm. About the size of pulsars?
Not about the size, no, just the mass and the density.
They have the mass. This one is about twice the mass of our sun.
Yes, very exactly measured.
Almost, yeah, almost. It's really interesting how close it is to almost exactly twice.
Yeah.
But based on what we know about it, it's probably about the size of a city on Earth. So you're talking about the mass packed into something that is just about 10 kilometers across, maybe 20 kilometers across. And so that means, and that's going to be true, that size is going to be roughly true no matter what the mass of the the pulsar is. Mm-hmm. So therefore, a neutron star is another name for a pulsar. So what that means is when you have something that's a high mass pulsar like this, that means the gravity near its surface is going to be about twice as intense as a similar mass, as a smaller mass pulsar, which are the ones that we've studied more. So what that means is when those pulses that Nicole talked about are being emitted, they're going to actually be slowed down as they pass out of the gravitational field of the pulsar. So that provides an extremely precise measure of the effect of gravity on these pulses of light. And that's in addition to the decay of the orbit. Its companion is a white dwarf. So as these objects orbit around each other, they're emitting gravitational waves, and they're getting closer together. So you've got actually two different ways in which they are in which gravity is providing us tests of general relativity. And general relativity is passed. We've got really tight constraints on any other theory that would predict different results.
So yeah, this being in a binary system, what the pulsar's been doing, they've been able to figure out pretty much the exact history of this system. As they get closer together, the pulsar increases its spin, and that's how you get a millisecond pulsar. That's how you get a pulsar that spins at several thousand times a second, 100 to 1,000 times a second. The other thing is that they use this to test, I'm not sure about the details of this, they wanted to test the regime where gravity waves can eventually be detected by future instruments such as LIGO. And so what they found is that the planned instruments for detecting gravity waves are consistent with the results that they found from the decay of the orbit of this particular pulsar pair. And so that's good. Yay, the instruments they're working on will probably be looking in the right search space for gravity waves.
Right. I mean, if I understand correctly, if I remember the things that Pamela has taught me, the gravity waves, I mean, these are still theoretical. They've been observed in these kinds of pulsar binaries, objects like this, but we haven't actually detected them passing through the instruments here on Earth, even though there have been some experiments. So, you know, this further constraint of what a gravity wave is going to look like as it passes through these instruments on Earth will really help to be able to discover them. So I think that's great. Yeah,
and like I said, the pulsar timing techniques, they get that down to 10 microseconds. Within 10 microseconds of when exactly the pulses come in. And so that's incredible precision. You have to take out the motion of the Earth, the motion of the solar system, all of this is just stuff. I'm going to include a link to how pulsar timing works for those of you who like math in the comments. The rest of you can ignore it.
the gist of this is Einstein still right.
And Pulsar's still awesome.
Still awesome. All right, well, let's move on. So, Jason, you've got a story of some cool meteors hitting Saturn's rings.
Yeah, well, let's come back from the depths of the galaxy and the universe down to our own solar system. So we know that there are always meteors striking Earth, striking the Moon, striking all the planets, really. I mean, one of the estimates is that like every day, 100 tons of just space junk, space dust, and bits and rocks and stuff like that comes, landing on Earth and contributes to the mass of our planet. Well, that's happening not just here, not just on the Moon, but also out in the solar system as well, past the asteroid belt. And a planet like Saturn is going to have, well, with all of the extra size and surface area, and the rings, of course, are going to add to that exponentially, it's going to be getting hit by meteors too. But they haven't really known how often this is happening until the equinox of Saturn back in 2009. And that's when, during Saturn's springtime, the light from the sun is hitting it at a angle right against the ring plane there. And what that does is it highlights all of the relief in the rings. Anything that's happening there really gets a spotlight on it. So by looking at the images that came back from Cassini from back in 2009, the mission scientists were able to see, and let me pop up this picture here. What we're looking at is these bright streaks and bright spots in the rings are actually the remnants of meteor hits. And so what happens is as the meteor strikes the rings, it kicks up all of that bright ring material. And because the rings are always moving, that stuff eventually gets pulled and sheared into these long bands, these long streaks. It almost looks like what we would see here on Earth up in the sky when a shooting star comes down, you get this long streak. Well, it's kind of like it gets frozen in time. I mean, I'm just using this as an artistic license here, but that's what it ends up looking like. Really, what that is the cloud of ring stuff getting kicked up, highlighted by the sun at that angle, and stretched out into this long band. And so that's, by looking at that, they're able to say, okay, well, this is how often Saturn's rings are getting hit by meteors, and what happens, and how fast the material in the rings is actually moving. So it doesn't take long for that thing to get stretched out either. It's only, within maybe one orbit around Saturn, 1.5 orbits, you go from a round cloud of dust, a poof, to something that's, stretched out thousands and thousands of kilometers. So
it's kind of amazing that there's actually a collision happening at all. When you think about, from this far away, when we see the rings, they really look like a solid object. But I know as you get closer, it's really just a collection of chunks of ice and dust and stuff. And so you can think about the actual size of the particles and the density of them with these meteorites moving through. The chances of one actually striking is probably not that common, but I guess there's so much material passing through the rings.
There's so much material,
and the rings are so big.
And it's so bright because it's all made of particles of water ice. So as soon as that puff happens, that stuff gets kicked out, hovers there for a while. It all goes into orbit around Saturn along with everything else, and it gets lit up by the rings. I mean, lit up by the sun, during that equinox period.
Right, it's scattering all that light all over the place. Yeah.
We have a question.
Go ahead.
Question.
Mole asking, at what speed are the rings of Saturn traveling?
Oh, boy.
Do we have does anyone have an idea?
Well, they travel with the orbit of Saturn.
Keplerian motion around Saturn.
Well, Saturn is. How
They're
fast
all
is it
traveling
turning?
at different speeds.
Right.
Yeah.
So
Thank you for translating.
and that's why the shear effect happens. Now, the average, the average speed. Well, let's see here on Earth, an orbital speed is 17,500 miles an hour. On Saturn, it would be, wherever they happen to be in altitude.
Right.
Really, how far out the rings are going. Closer into Saturn, those particles are moving faster than. Well, actually, no. Closer into Saturn, the particles are moving slower. Further out, they're moving faster.
And then you've got Saturn's movement around the sun, but then you've got the micrometeorites. Who knows what direction they're coming from? So Yeah, so I mean, there's all kinds of combinations that can happen. And you had another picture. I just wanted to sort of switch. You had another picture you're going to show as well of that infrared image of Saturn.
Super cool here.
Yeah, this is beautiful.
We're super hot for being
All right, this here is an infrared image of Saturn taken from the Keck Observatory in Hawaii by University of Leicester scientists James Donahue and Dr. Tom Stallard. This past Sunday, there was an observation, well, there's going to be a series of observations using Keck's infrared ability to look at Saturn and see the heat signatures there. And, well, I mean, you can just see right here how gorgeous this is, you know. The planet itself tends to disappear right into the blackness because it's not reflecting nearly as much light and nearly as much infrared radiation as some of these segments of rings. But this is just gorgeous. Now, this is this image here is tipped 90 degrees from the original, but it's just, you know, it's beautiful, absolutely beautiful.
So we're seeing the inner rings glowing a lot hotter.
You're seeing the inner rings glowing. Yeah. I would have to, and I'm just making an uneducated guess here. I would have to think that the inner rings are brighter because they're probably denser and probably reflecting a lot more visible as well as infrared radiation back at us. The same thing as the outermost ring, and I want to say that's either the edge of the A ring or the F ring all by itself.
Is it a reflection or is it emission because it's so warm?
Yeah.
It looks like emission, but I don't know anything about the physics going on here.
Well, if it's getting optical reflection back, isn't there a possibility that it's also reflecting a bit of infrared back as well?
Sure, but that's not what this looks like. That's
it,
my
especially with the density there around the planet. It definitely looks like it's emitting that, and I don't know if it just has to do with the amount of energy that's there just because of the tidal forces and anything like that going on.
I think we without knowing more about the observation, we're speculating, but it's pretty. That's what's important.
It's a pretty picture.
It's gorgeous.
Yeah. So we've been joined by Alan Boyle, which is awesome from Cosmic
Hi,
Law.
sorry I was late. Technical difficulties. So.
Oh, no problem. And I think now you have a silly picture that you're going to share.
Oh, that's part of the technical difficulties that I can't actually share it, but
let me see.
I can share it.
Scott can.
Scott can share it. Then
Okay.
Scott can share it, and you can talk about it.
Oh,
all right, everybody.
The phallus on Mars. This picture actually is from 2004, shortly after the Spirit rover landed, but it generated a new wave of hilarity this week when it started popping up, so to speak. It looks like a little piece of anatomy there, and so people were, there were some reports like the Sun or the Daily Mail saying that, gee, those NASA rover operators must be getting bored. There's actually a TV host in Britain who hosts a racing show, and so he did some tire tracks that looked like a male member as a joke, and so everyone picked up on that and thought that the NASA rover drivers were doing the same thing. Well, it turns out that this is just the standard pattern that the rover leaves behind when it goes along a track and then has to turn its wheels around, and so you could see this pattern many times on Mars, but I
didn't realize they're so sophomoric.
That's right. Yeah. Actually, there's a well-known rover driver, Scott Maxwell, who says that he thinks he had a role in actually doing this particular pattern, and is very proud of it. So
that sounds like Scott.
It doesn't really have any scientific relevance. It's an interesting little engineering
Penis
tutorial.
pareidolia.
That's right. Penis pareidolia. I like it. I like it.
I gotta say, Alan, this gives a new meaning to the term space junk.
Yes.
And they say I bring
all
some
like,
hard humor. Look at you guys.
One of the Twitter commenters said that you might think that there's a phallus on Mars, but it's actually a fallacy.
That was me.
That was you.
There you go.
That was me. Although I think I stole the joke from Terry Pratchett. I may be wrong on that, but the joke is not entirely my own.
Well,
So-
it is really hard to make these jokes.
Oh!
Okay, you know what? I'm going to
Moving
shut
right
this down.
along.
Shutting this down. We are moving
Like
on.
the
Save the
rover.
silliness for Sunday night.
This will. I know these people, and I know where this is going. So we are shutting it down
You
right
are
now
one of
before
us,
it.
Brady.
There are so
goes
many
too
double
far.
entendres in that sentence.
Someone's got to be the adult here.
Okay.
Okay.
Wait,
So Scott,
can I, unrelated to Mars, we had a brief question from Guido Bibra about the previous story. What are we going to do without Cassini? Is the mission really ending in 2017? And then what are we going to do? And I think there's nothing else scheduled to go out to Saturn after Cassini. Cassini's already well into an extended mission, so we are getting way more time than they had
A
originally.
couple of extended missions, yeah.
Yes. Right.
Yeah, eventually Cassini, at the end of its mission, is going to be sunk into Saturn, similar to what Galileo did at Jupiter.
That's to prevent
And I mean, it's,
contamination.
right.
it'll be glorious, but it'll be a sad ending because we all love Cassini so much.
and
That's
then
a
we'll
big
hear the
concern.
rumors that it's going to turn Saturn into a second star. Mark my
As in
words. You've heard it here, right
2001?
here.
That's a big concern, actually. I think Robert Pappalardo at the AAAS meeting voiced concern that we're really going to go radio dark in the outer solar system once Cassini and Juno bite the dust. So all we've got is New Horizons and Pluto. So don't be so quick to throw Pluto out of the fold.
Now, speaking of Pluto, you had a note about their moons, Alan.
Oh, yeah. So, as you remember, there was this project called Pluto Rocks, which let hundreds of thousands of people vote to tell the scientists on the Discovery team what their favorites were for naming the fourth and fifth moons of Pluto, P4 and P5. And the favorites turned out to be Vulcan and Cerberus. And Vulcan, of course, is where Mr. Spock is from, and so William Shatner gave that name a big boost, and it turned out to be the #1 choice by a long shot. Yeah. So the question was, well, are they actually going to suggest these names? Because there are a few problems with each of those names. One is that Vulcan was the name of the supposed planet that was inside the orbit of Mercury until they figured out that general relativity was a better explanation for what the orbit of Mercury was doing. And so they wondered if the IAU, which is the body that approves these names, would go for Vulcan. And then Cerberus, there's already an asteroid named Cerberus. And so it's not a slam dunk that they would have gone with these names, but it turned out, word bubbled up that they are indeed proposing those names to the IAU. And I have to say that Nature's Alex Whitsey had this indication from IAU sources, and so I just followed up with Mark Showalter from the SETI Institute, and he said, yes, that is the case, that even though Vulcan is the god of fire, and it's a little problematic to name an ice ball after the god of fire, he's making the argument that Vulcan did live under a volcano, so technically he lived in the underworld, and he was something like a nephew to Pluto, so there's a family connection there. And in terms of Cerberus, what you could do is change the spelling of the name. For example, there's another moon of Pluto that's called Nix, but they spell that N-I-X because there was also already an asteroid named after after the Greek god of the night, NYX. And so if you name it Kerberos with a K, you might be able to get around that potential confusion problem. But it might not be too long and we'll hear the official word from the IAU about what they're going to go with. And so we may have Vulcan in the family coming up. So live long and prosper, Pluto and its moons.
I think they should have waited, to use the Vulcan. Like, wait for a bigger object, a better, a more appropriate place for Spock's homeworld.
Well,
Either
there's
an
not gonna be
extrasolar planet at Epsilon Eridani, or you know what I mean? Like that's what I would do.
I know exactly what you mean. That there's not going to be a bigger object unless Planet X is found somewhere in the Oort cloud in our own solar system.
Yeah.
But I know what you mean about that whole issue of exoplanet naming, and that's another whole.
It's just such a tiny little moon of Pluto that it's such a. I mean,
once William Shatner piped up on Twitter, I mean that was it. The whole thing. Really grew rocket wings.
And I think
for Denny Crane bump.
I think for people who think that it's not appropriate to name astronomical objects after popular TV shows, think about the moons of Uranus, which are named after Shakespeare's plays, right?
True.
So,
but with Pluto's moons, they're typically named after Roman or Greek mythological figures, and it just turned out that Vulcan is a dual-use name because it's not only Mr. Spock's planet, but it's also the god of fire in mythology. So they were able to make that case.
Right. Okay, well, we're going to move on. Scott, you've got observations of Betelgeuse using a radar array.
Yes, with Betelgeuse or Betelgeuse, it's up in Orion, and it's around 640, 650 light years away from us. So it's actually really, really close, and it's this huge red supergiant. But they've been using a radar array with Emerlin over.
Stop saying radar, both of you. Radio.
No, radio.
Oh, radio.
Excuse me.
Radio array. Sorry.
Put it into my head.
Did I blame him?
Right, my fault.
All right. Well, here's an image
Radar
of
sends a beam
the
out
array.
and then comes back. Yeah.
So this is showing the different observatories all over England with Emerlin. And Emerlin stands for the Multi-Element Radio-Linked Interferometer Network. And so what is actually being observed here is that far larger than the optical observation of the star, you're seeing the atmosphere so far out. And there's a couple images released by the University of Manchester about this, and it just gives you a little bit of insight, because it's such a huge star anyways. It's much, much larger than the sun. But you can see here this little circle right in the center is what we can see in visible light. And this is all of the atmosphere itself puffed out into space. It's so much larger than what we can see with visible light. And it's not able to be seen in visible light. We have to actually see it in radio. And to have another bit of context to it, we can see our solar system placed inside of this. So here's Neptune and Uranus and Saturn and Jupiter, all the way inside just the atmosphere of Betelgeuse. And we're seeing something a little interesting up here with the atmosphere actually being sloughed out, and it's really hot. Hot as far as space goes. It's around 150 Kelvin, and there's so much of it. And they're seeing around 3 Earth masses every year is being jettisoned out of the star itself from the solar winds that are coming from it. So it's really interesting in how they're able to get a lot of this new data coming through with such a difficult way. And I know Nicole can go in a little bit of detail about how hard it is to get such a detailed analysis of a star like this using interferometry and radio light.
Yeah, the power of radio interferometry is that you can get these very high spatial resolution images. You can actually resolve what's happening around the star, but it's difficult. And in particular with Merlin, I think they're using very long baseline interferometry techniques, and so they're all different antennas, and so you have to calibrate the whole system, and they're not identical, and that makes it a little bit more difficult as well.
And if you're not familiar, if you're watching and you're not familiar exactly where Betelgeuse is, or Betelgeuse is, or however you want to pronounce it, it's the very, very visible top left star in the shoulders of Orion. So you can see it in the image right there. So it's something that's very much a visible star in the night sky for much of Earth.
And it's going to go, it's going to go supernova. Not might, it's going to, in the next few million years.
Million years, right?
Yeah, maybe tomorrow, maybe 10 million years.
Do we know if we're looking at Betelgeuse?
You did that one.
edge on? Is it edge on, or are we looking at it?
There's no disk, really. I mean,
Right.
it's all sloughing off.
Because the density of it, so, it's just so out there.
Because it's such a large star that stellar winds are going off in all directions, and that's what's going to end up polluting the space around it.
So no planets around there.
Not that I know of.
Inside the star. All right, let's move on.
That's where Vulcan is inside of Betelgeuse.
Right.
That's right. So Nancy, we've got a story from you about the Progress arriving at the International Space Station, not without a hitch.
Yeah. Well, shortly after the Russian Progress 51 launched from Russia, or the Baikonur
Baikonur Cosmodrome in Kazakhstan?
Kazakhstan, thank you. On Wednesday, people in mission control realized that one of the docking antennas wouldn't deploy. And so there was some initial doubt about its ability to dock, one, because this is one of the very crucial antennas for docking. It helps keep the ship oriented to the station using the KERS automated docking system. And then two, also because this wasn't deployed, it was kind of stuck in the spot where where Progress would come together with the space station. And of course, some news sites were saying the ship was lost and all the supplies and equipment would never reach the station. People were going to be in bad shape, all this kind of stuff. But I was pretty certain that they'd figure out something. And basically all they did was send a software patch up to the Progress, and one of the other antennas was able to do what this one normally does. And so this morning it approached normally, and actually they ended up docking successfully 2 minutes earlier than they had planned. And it was kind of funny though. It was they did a soft dock at first just to make sure that this wasn't going to be a problem when they got the two really close together. And the funny thing was that they, to make sure things weren't getting wrecked, they asked the astronauts and cosmonauts to listen to see if they heard any funny sounds. So.
Oh, that's something you want to hear.
Yeah. Are you hearing any funny sounds? And they said no. So
just the voices.
The crew is right now unloading the Progress. So everything turned out just fine.
And that is not the only story in space flight news this week. We've got the Antares launch, which is actually a really exciting development. I know, Matthew, you tried to watch it. Oh, you're muted.
Matthew,
there we go.
There you go.
Yeah. Well, I was trying to bring up the image. This is a photo I took, actually. I went there for the first scheduled launch on Wednesday of last week, which was the first of 2 aborted launches. That one, they called it off at the T-12 point because an umbilical cable, cable connecting the second stage disconnected early. That kind of thing happens, but of course you can't launch the rocket if you don't have all the cables attached when they need to be. But the launch went off on the 3rd attempt on Sunday without a hitch. It was one of those absolutely perfect launches. Nothing went wrong as far as anybody I've talked to can tell. But the Antares rocket is actually a general purpose rocket. The first purpose to which it'll be put is resupplying the space station, making it one of several vehicles, including Progress, designed for that purpose. But Antares is also general purpose enough that it could conceivably carry much bigger payloads in the future. One of the test devices, actually 3 test devices that it had as payload during the test launch was it contained 3 phone sats, which are small cube satellites containing Android cell phones. These are basically in Sputnik mode right now. All they're doing is sending back a signal to Earth your pre-programmed signals. They're not doing anything new. They're not being told anything. So it's one-way communication. But the fact is, these are little bitty. These are 10 centimeters on the side. So
CubeSats are awesome.
they are very cool. In fact, I tried to carry off one that they passed around to the media people at the event, but they wouldn't. They saw it under my coat, so I didn't get to carry it home. But
Don't say such things on live broadcast.
I probably should have carried that, shouldn't I?
Stop trying to root the CubeSat, all right? I know what you're trying to do.
So if the NASA guy that I talked to is listening, I'm sorry for joking about such things. Please don't deny me access in the future. But in any case, but these are really interesting things, and we'll be hearing more about CubeSats as more of them are deployed.
But I think what's really interesting about this is another private rocket company, right? This is Orbital Sciences, sort of in the same vein as what's happening with SpaceX, with Elon Musk's SpaceX. So you've got, I mean, this whole private space launch space is really starting to open up now, with multiple groups developing fairly low-cost rocket companies, rocket solutions, and this is really going to take all of communication satellites, space exploration, private space launches just to the next level. So I think this is fantastic, and there's a lot of real sort of great things happening in this marketplace now.
Yeah, and Orbital's been around for 20 years too. That's
no,
another
but just
thing to note.
the fact that they launched it, right, and it's a pretty beefy rocket.
It is, yeah.
And I love the fact that it's becoming so much easier for smaller groups to be able to send payloads up there with it. With Android and Arduino being able to do CubeSats and sending things up and having small little research projects and just being able to group everything together and send it up. So many more people are able to do science in space that you never thought would ever be possible, because you were thinking just governmental space agencies are the only ones able to do research, and now it's really open to the public.
Yeah, and you can use you can put together CubeSats like Lego blocks too. For example, Planetary Resources talked about their plan to fly a prototype instrument test package into space next year, and what they're doing is taking 3 of these 4-inch by 4-inch or 10 centimeter by 10 centimeter CubeSats, putting them together, and then just stuffing them with the equipment that they want to test. So you've got Legoland in space.
We have a question from Kelsey Jewett asking, what about more space junk? Is this going to create a lot more space junk with all this stuff going out?
Ooh,
I guess
a question.
I mean, it depends on the orbit, right? I mean, if the orbits are fairly low Earth orbit, and if the spacecraft isn't going to last very long, then it won't be a long-term problem. If they're a higher orbit, they can last years or even decades. So, but there will be more space junk. I mean, we are, with launch costs coming down, SpaceX wants to bring the cost of launch down by a factor of 10, and then at the same time of this miniaturization of spacecraft and the cheapening price. I mean, the price for satellites is now dropping by a factor of 10, and it's getting to the point now where average groups could get together and launch spacecraft. So yeah, absolutely, more space junk.
More space junk, but it was a few months ago we actually did a story in the Weekly Space Hangout, and how they're actually trying to go through and gather up stuff that can be recycled and be reused. And even though it's older technology,
well, that's an idea to do it. That's not it's feasible technology. Yeah.
But it's still something that you might be able to do something with at some point.
They've also talked about deorbiting some of these larger pieces using lasers and all sorts of fancy stuff like that. So there may soon be a way that we can start cleaning these things up.
Pew pew.
Yeah, exactly.
This is an actual. By the way, this is an actual CubeSat that I got to hold. So that's my hand in the picture. Pumpkin, yes, I love that. And I also like the fact that it says consult user manual prior to operation.
Before you launch this, read the instructions.
Yes.
Yeah.
I think it would be cool to market replicas of that. I wouldn't mind having a little CubeSat on my desk, even if it's just a fake one.
A little pencil sharpener.
Yeah.
Well, moving on, we're actually not doing too badly now. We've got Hubble observations of Comet Ison, the comet of the century.
Yeah, so one of these big comets that's coming in was imaged by the Hubble Space Telescope. I think I'm screen sharing now. Yep. So this is, the best look we have at the comet so far. It's on its way into the inner solar system. When do we think it's going to be visible? I don't remember.
November.
November. Mm-hmm. But what they found is it's kind of the body of it is kind of a small comet. It's 3 to 4 miles across. The actual rocky. I'm using my hands uselessly back here, but it's about 3 to 4 miles across the nucleus of the comet, and then the coma bit is about 3,000 miles across. So 1.2 times the width of Australia. So imagine a glowing Australia moving through the solar system, and that's about the size of Comet Ison's coma. So yeah, that's pretty much it. Oh, and dust tail extends 57,000 miles.
Now, Alan, I know you reported on this story as well. Do the Hubble observations have any impact on sort of the predictions that this will be the comet of the century?
Actually, there's a debate about that because the nucleus is so small. Some people are thinking that this is not a good sign for having a spectacular comet because there's just not enough there. There's a possibility that the thing could crumble, break up as it goes around the sun. So the fact that the nucleus is relatively small is leading some people to wonder, well, gee, that's great that such a small nucleus is able to present such a large amount of activity right now, but how much staying power is it going to have? So that's a big issue.
It could pull a Lovejoy. I mean, just pop around the other side and put on a great show as it heads out.
Or it could pull in Comet Elenin. I think you mentioned that. Comet, the Doomsday Comet that met its doom early.
And not destroy the Earth.
And speaking of that, there are some doomsday and conspiracy theories out there about Comet Ison, and so David Dickinson for Universe Today is going to be having an article debunking all the nonsense on Monday. So,
Dave, you are awesome.
Oh, that's going to be fantastic. Please, I can't wait for Dave to do that. Dave's great.
Aw. He's taking over Ian's old doomsday.
And Dave, I think David's going to be joining us in future Space Hangouts, and he's fantastic. He also helps us on the Virtual Star Party, so he is in all places everywhere and is great.
He knows his stuff. Is going to be on November 28th. I just looked that up. So it's going to come within 800,000 miles of the sun. So that's really, really close.
Yeah.
But that's when it makes
such a little ball of ice.
So Nancy, can you talk about the grasshopper test, which is also awesome? This is a great week for space, I gotta say. This is very cool. So
this is really fun. SpaceX wants to eventually to be able to land vertically on land and not splash down in the ocean, and so they're working on what they call the grasshopper. It's a 10-story high rocket that just basically it's a vertical. Oh, shoot, I forgot the
takeoff and landing.
Landing, yes, that's what it is. And so basically, they go up and hover a little bit, and then they go down. And so earlier this week, they did the highest one that they've done yet, and they had some really cool footage because they have SpaceX, of course, has all the gadgets.
I can show it if you want.
Yeah.
Play that.
You want to show it?
I've muted the sound, so.
Okay. And anyway, SpaceX has a hexacopter, and they had a camera on board, and so you have the footage of it from above, and so it's just kind of hovering, and it's cool. You can watch it here, and
so
watch out!
If you're
watch out, helicopter!
If you play with sound, they're playing Ring of Fire. Over
you got to make sure you watch the original.
Yeah. So anyway, it flew up to 250 meters, which is 820 feet. That's the highest it's gone so far. This is its 5th test flight. And Elon Musk said via Twitter that it was actually kind of a windy day, and it was a really good test because...
It's just hanging there?
Yeah.
It's coming down!
Yeah. So
it
actually
looks like the lab on the bottom.
It actually was really stable, even though it was kind of windy, and so they were very pleased with that. And then it just lands nice and softly. So that's
freaking kidding me.
Yeah.
Oh my God.
That's exactly what I said when I watched that.
I'm flailing. You can't see me flailing, but I'm flailing.
Oh wow.
That is just amazing. But I mean, go ahead, Nancy.
Okay, I was just going to say that the Grasshopper is made out of a Falcon 9 first stage tank, a Merlin 1D engine, 4 steel and aluminum landing legs with hydraulic dampers. So that's what it is.
And the dreams of every 1950s science fiction author.
Yeah.
So they usually have a cowboy mannequin sitting on the platform, so I'm curious what happened to the cowboy in the wind.
Oh my god.
So what are the practical uses of the Grasshopper? I mean, it seems like, you know, a very fuel inefficient way to launch a rocket to have it land. I mean, I know that, like, one of Elon Musk's big concerns about the whole space launch thing is that, you know, it's not the price of fuel for getting things into orbit. The fuel is only a couple $100,000 for a rocket. It's the price of the rocket itself, which is essentially disposed of after every launch. You know, you're taking, imagine every time you drove your car for groceries, you threw it out and bought a new one. So, you know, that's the problem.
You just answered your own question, Fraser. That's why they're doing the Grasshopper.
Well, I understand, but I guess but to take that thing and to be able to have it go up is one thing. To have it be able to kind of come back down and land is a whole other
I think
world.
The first thing that they want to be able to use it for is maybe not for takeoffs, but for landing. They want to be able to have, like the Dragon, to be able to land on land vertically.
Right, but I'm just wondering if a rocket can have enough fuel to go all the way up into orbit, release whatever its payload is, and then deorbit itself, and then land again. Essentially, you're needing double the fuel, right?
Yep.
But I think that's the point. The point is to go somewhere and then be able to come back.
That's the aim. That's why Elon is doing it, is because he wants to get to that point where you have true reusability of the first stage that flies it back to the launch pad. And so, yeah, you're right that it's going to take some more work to be able to do all the logistics you need to do to have enough fuel left. But that's why he's doing it.
On orbital fuel stations.
Right, I understand. So you could so you could have that first stage launch off, give as much velocity as it can to the rest of the rocket, and then detach, and then it just returns perfectly back to its landing site. So yeah, that actually does make sense.
Although you could just turn it into a theme park ride, Slim Pickens from Dr. Strangelove, and just ride it out.
Awesome. Okay, so I think the last story that we wanted to cover was just
several more.
I know. Well, the one that I've got on my list still is the lunar eclipse that happened just a couple of days ago. We've got just a few pictures. I know.
There was a lunar eclipse.
Yeah,
Yay.
On the 25th.
So it was a very tiny lunar eclipse. Only a little bit of the moon was actually eclipsed into shadow. So there's a whole series of pictures over on Universe Today where you can see this brief partial eclipse. I like this one with the plane flying through it, and so you actually get the plane and the contrail in it. That's pretty much it. I think there was an amusing tweet from, I don't remember which organization, saying that the full moon coincided with the lunar eclipse, and a bunch of us giggled because that's the necessary condition for an eclipse. It has to be a full moon. But that's okay.
That only happens once every lunar eclipse.
Once every lunar eclipse. So go to Universe Today. I will put this link in the comments as well and check it out. Like I said, it's just a little tiny bit of the limb of the moon was covered. So not terribly dark, but there was one. There was two more things I wanted to mention. One, because Amy unfortunately had to drop out because she was having sound issues. She wanted to talk about Mars 1, which is the Dutch reality TV show to be set on Mars. That would have been cool. They did a press conference earlier this week, and I'll put the link again for her story. Basically, she told me to tell everyone that they are being a little bit unrealistic. They claim that the technology already exists to do this entire mission, and they seem to be dodgy about the funding sources. So she wasn't terribly impressed by their press conference, and so I'll include that link as well.
Where will you get $100 billion? Yeah.
$100 billion.
They're saying 6.
6 billion. That's what they said. 6 billion. What? And then one other cool thing I wanted to share is
advertising.
Yeah. There was a contest that happened in New York, and I think the international part of the contest is called the Space Apps Challenge. is happening next week, and I think we will have the winner of the New York version on Learning Space on Wednesday talking about this. And so he made this really cool app that I'm going to share that shows you all the locations. From what I can tell, I think this is all the locations on the sky that are being looked at by various space telescopes over the next some period of time. I don't know entirely what time period it is, but all those blue dots are Herschel, which is an infrared observatory. And so you can see all the spots that they'll be looking at. Suzaku is X-ray, I think. Where's Hubble? Hubble is green. I'm not seeing it. It's like one green spot. So he's gone through and picked up all of the observing schedules for these space telescopes and is showing you what is being looked at in the sky.
That's really cool.
Which is pretty cool.
Okay. Now are we caught up? Have we got any questions that people want to hit us with?
One question I wanted to bring back from the Betelgeuse story from Rob Kroll, asking if we know how many visible naked eye stars can turn supernova. And I don't know the number precisely, but a large number of the stars that we can see with the naked eye are large stars, because the larger the star is, the brighter it is, the further away we can actually see it with our naked eye. So any star that's above 8 solar masses is going to go supernova, and I don't know offhand how many that is out of the visible stars, but that's quite a lot, because, like I said, by nature, the stars we can see with our eyes tend to be the big ones.
Right.
There's a bias there.
But most of those aren't going to go boom anytime soon.
And
Unfortunately, we'd love it. We'd love it if they would.
Yes.
We want to see one go boom.
Yeah.
And none of them are close enough that they would really cause damage to
So,
life on Earth.
Insider PWH asks, what is the ultimate goal of the Grasshopper demonstrations? It's not just to show off, is it? And I think that's what we're getting at, right? Which is that the goal of SpaceX, the ultimate goal is to come up with a completely reusable spacecraft that they can launch and then just fill it with fuel again and launch again and then fill it with fuel. But it really is pushing the very limits of material science, and so I think they're breaking it up into bits and pieces, and in this case, let's try and get that first launch stage reusable. So
this particular launch just showed that they could reach a height higher than they had reached before and still land safely and vertically. So that's what this last launch was.
Yeah.
Well, and it's funny because you were saying it was windy, and you can actually see the effects of the wind on the craft itself, and the way they were able to correct all the way down. That was just phenomenal feat of engineering, let alone just how cool it was.
Yeah. So Alan, could you imagine in the next few years we might see like another stage perched on top of it, and then the whole thing is used in a launch?
Well, sure. I mean, SpaceX is upgrading its Falcon 9. It's going to have what they call 2.0 coming up for the Dragon, and so you might see more of an incremental application of different technologies that kind of get you to that point where you see the Red Dragon landing on Mars and the stages that fly themselves back to the launch pad. So Grasshopper is kind of a test bed for those sorts of technologies.
All right. Well, I think we're sort of nearing our hour. So why don't we wrap this up?
We fit all those stories in an hour.
That was a lot of stories.
Yeah.
That was good. That was fast. I hope people, were able to hang on for the ride. So let's kind of go around, and we'll make sure that people know where to find out more about all of the journalists who participated today. So first, we'll go backwards now. So Alan Boyle, where do we find out more? Alan Boyle.
Well, you can go to cosmiclog.com, let's see. Let's try science.nbcnews.com or B0YLE on Twitter. So there you go. Facebook, all the usual places.
Yep, and Google Plus.
Google Plus.
Yep. Scott Lewis, where do we find out more, Scott?
Everywhere. Let's see here, knowthecosmos.com. I'm the Bald Astronomer on Twitter, Facebook to a lesser extent. I also with the virtual star parties on Sunday, and I also have another show this Sunday before the virtual star party with my co-host Budini, with Dr. Vincent. I will mispronounce his name horribly, but we're doing one with Science Sunday on virology. So
Awesome.
all over the place.
Nice. Dr. Nicole Gugliucci.
Hi, I am Noisy Astronomer, and I work for CosmoQuest. Find out all the cool stuff we do at cosmoquest.org. We have a bunch more shows coming up this week, like Learning Space, which I mentioned on Wednesday. And Pamela Gay and I are also planning for the weekend of June 15th, a 24-hour Hangout-a-thon. So there'll be more details coming up about that in the coming weeks.
Yikes.
Yeah, fundraiser hangout. We are going to go crazy online for you.
And we are going to watch it happen. Yep.
You're going to be part of it, Fraser.
I know. You're going to rope me in. I know. I'm ready. I'm ready to help. Nancy Atkinson, where do we find out more about you?
You can find me at Universe Today, mostly. I'm also at the NASA Lunar Science Institute podcast, and I have a new podcast out today where I interviewed the author of The Overview Effect. So that's there. I'm at Nancy_A at Twitter. I'm also on Facebook and Google+.
Awesome. Dr. Matthew Francis, where do we find out more?
Primary site is bowlerhatscience.org. That's pretty much the go-to place where you can find all my Twitter, G+, Facebook, cat. Pardon
tail.
Me. Here is,
yeah.
You feel like
this is Pascal. Hello. Say hello to the nice people, Pascal. Next time, shut the cat out. You can also find me this week only at the New Yorker, but also Ars Technica, and my blog is at galileospendulum.org.
Awesome. And Jason Major.
I live over at lightsinthedark.com. I'm also on Universe Today. I write for Discovery News Space, and I'm on Twitter at JPMajor, and Facebook and Google+, and all sorts of other fun places like that. And here on the Weekly Space Hangout.
On the Weekly Space Hangout. Awesome. All right. Well, thanks, everyone, for joining us this week. Thank you, everyone, for watching, and we will see you all next week.
Bye, everybody.
That's it. We've got Dr. Nicole Gugliucci,
hello,
a.k.a. the Noisy Astronomer from CosmoQuest. And we've got Scott Lewis,
hey, everyone.
My partner in crime with the Virtual Star Party.
That's right.
Okay, so then we're just going to start with, I think we'll start with Nicole, and we're going to talk about this really cool test of general relativity.
Pulsars, pulsars, pulsars. Pulsars are awesome. Okay, so this story broke yesterday. I don't know if you mentioned about comments. If you want to comment,
right,
do it
of course. I'm doing a terrible job. Let me get
No.
So yeah, we love
make
your
room for
comments. We love to incorporate your questions into the show. So if you want to do that, you can go to if you're watching this on the event page on Google+, you can post your comments there. If you're watching this on the stream somewhere, you can post your comments just in Google+ on the stream. Hopefully we'll get it. I can't guarantee that. Also, if you're watching this somewhere and you just want to use Twitter, you can use the hashtag #SpaceHangout, or you can use it on. You can post a comment on YouTube. YouTube's probably the safest place, so we'll absolutely we'll catch it on YouTube. So go ahead and post any questions. Although I'm not sure we're actually getting the YouTube video automatically. Actually, now that I think about it,
it was
in the comments.
already listed there.
Yeah.
It's taking its sweet old time if it is.
Okay. Yeah. So
there's a comment. Thank you,
there
Tyler.
You go. Post your comments. Awesome. All right.
All right.
So Pulsars. When last we saw our heroes, it was Pulsars. Pulsars are awesome, I believe.
Pulsars. So there was a pulsar pair discovered. It's actually a pulsar and a white dwarf star. And the pulsar has the name of PSR J0348 plus 0432, of course. This is this is a very interesting system because it's usually they do this test with pulsar binaries. This is a very close binary of a white dwarf and a pulsar. Pulsar is a neutron star, so it's this very dense material. It's so dense that it's all compacted, all the particles into neutrons, and it's got this these beams of light spitting out of both sides, and as it's spinning very rapidly. This one's on the order of 30 milliseconds. This is a very rapidly spinning pulsar, and it's got a white dwarf orbiting it. And so they were able to, a group of scientists, including a bunch of my friends from University of Virginia and the National Radio Astronomy Observatory, they detected the system with the Green Bank telescope, and then they did follow-up using optical telescopes, I want to say at Apache Point, as well as Arecibo, the Arecibo radio telescope. And they found out a couple of interesting things about this system.
Well, one of the things that's really interesting about this particular pulsar is, one thing, back up for a second. One thing that is interesting about pulsars in general is that they are so small in relation to their mass. So a pulsar, did you already say this, Nicole?
Mm-hmm.
About the size of pulsars?
Not about the size, no, just the mass and the density.
They have the mass. This one is about twice the mass of our sun.
Almost, yes, very exactly measured.
Almost, yeah, almost. It's really interesting how close it is to almost exactly twice.
Yeah.
But based on what we know about it, it's probably about the size of a city on Earth. So you're talking about the mass packed into something that is just about 10 kilometers across, maybe 20 kilometers across. And so that means, and that's going to be true, that size is going to be roughly true no matter what the mass of the neutrons, the pulsar is. Mm-hmm. So therefore, a neutron star is another name for a pulsar. So what that means is when you have something that's a high mass pulsar like this, that means the gravity near its surface is going to be about twice.
So, hi everyone, my name is Fraser Cain. I'm the publisher of Universe Today, and it is your weekly space hangout for Friday, April 26, 2013. There's a cat there, right there. So today we've got so many stories. I am going to be amazed if we'll be able to make it through them. So if you feel a certain sense of urgency from me, that's because there's a ton of stories. We've got a new test of general relativity. We've got meteors hitting Saturn's rings. We've got observations of Betelgeuse. We've got, Hubble observations of Comet Ison. We've got progress arriving at the International Space Station with a few glitches. We've got a lunar eclipse that just happened, the launch of the Antares rocket, and the test of the Grasshopper, and more. So we're gonna be talking about a lot of stuff. So joining me, fortunately, we've got lots of help. So we've got my good friend Jason Major. We've got Dr. Matthew Francis, who joined us last week and is back with, who's the cat? Oh, you're muted, I think.
The cat is Dr. Matthew Francis. Who's
Dr.
that?
Matthew. Oh, I see.
The cat is actually
that Futurama episode, right?
This is Pascal, and I will remove him before he starts yelling, which is what he's likely to do.
Awesome. We've got Nancy Atkinson from Universe Today.
And the VLT in Chile.
And the VLT. Right, the VLT in Chile. Thank you. So they discovered a couple interesting things about this system. First of all, they were able to determine the masses of the pulsar and the white dwarf with extreme precision. That's really hard to do. And so they discovered that the pulsar was two solar masses. And then they used a technique called pulsar timing, where they actually measure the time that each pulse comes in from the pulsar with an accuracy of 10 microseconds. So with an accuracy of 10 microseconds, they can get the exact orbits and the exact motion of this system. One thing that they found is that they could use this to test a regime of general relativity that they haven't been able to test before. The general relativity is this theory of gravity that seems to work in all cases, but we know it probably breaks down somewhere because it doesn't mesh with quantum mechanics, right? And so physicists are looking for this grand unified theory of everything, and so they're looking to find the places where general relativity is going to break. Turns out this was not the place.
Einstein was right again.
Einstein was right again. But it's a new search space that has been probed that way. I think Matthew, maybe you're a little bit better schooled on general relativity than I am. If you want to talk about some of the implications